Hello, welcome to a new subscribe episode, this time from my office. As you can see, pictures behind me. Today I'm going to talk about what we're releasing today, and that is the new SDK 2.0. Don't be too worried about the 0.0 at the end. It's not a revolution, it's an evolution. So we're adding new features in Service Bus, but you'll notice that the entire Windows Azure SDK goes to 2.0. And I think it's a timely thing because we've been going 1.0 in January 2010, and it's hard to deny that there's a lot of activity that has been going on in Windows Azure, so we're going to mark this with making this a 2.0 release. I'm going to be talking about this in the next several minutes about what we have new in Service Bus per se, a few changes, a few additions, a few improvements, and I'm going to demo those things over the next few weeks in Code and Visual Studio, but I'll show you the code on slide here in this presentation today. So the first feature we have is Message Browse, something that people have been asking for. Most of the other features that we are adding are based on customer requests. So the first one is Message Browse. Message Browse allows you to look into a queue, look into a subscription at the current state, what's in there. So instead of doing a receive operation, either with pclock or receive and delete, you can actually now go and scroll over the messages and see what's there, kind of taking a snapshot. So if you're building diagnostics tools or you want to inspect the content of, let's say, the letter queue, that's what I meant, then you can do that. So several options here. You have a peak. You have a peak where you can start from the sequence number, and you can also do a batch operation. So that gives you a way to diagnose, to kind of peek into the state of a queue. And so if you're building some tooling, you can use that functionality for that. There's also new options for how to deal with entities if you want to go and shut them down from either side. So if you, for instance, want to disallow send operations into an existing queue, but still want to be able to drain them, or if you want to allow sends, but you don't want to go and allow clients to receive them because you want to go and do some upgrades, you want to coordinate sends or receives in this way. We've added those two options, a send disabled and a receive disabled operation on the entity status that you can set on queue description, but you can also send those on the other entities. And so that's very useful, for instance, in multi-tenant applications. And you can pause with that, the enqueue and dequeue, and then resume it. And when an enqueue or a dequeue, a send or receive is attempted, the receivers or the senders will get an error that will indicate that the entity is currently not available for that operation. Something that we also got as a request was support for more volatile entities. We are making them still as reliable and transactional as we have done that before. What we're adding here is an auto delete operation. What that allows you to do is effectively set a timeline, a TTL for a particular entity, after which that entity will be automatically garbage collected by the system. So here on the slide you see it's 30 minutes, which means if there's no activity whatsoever, no send, no receive, and no metadata update, as you've seen in the previous slide, when you go and change the status of an entity, that's a metadata operation. If you don't see any of those activities, then the entity, may that be a subscription or queue or to topic, gets automatically removed from the system. What that's useful for instance, is if you have multiple worker roles, they all are feeding on a topic, and a worker role crashes, goes away, it can go and now create a subscription for itself, doesn't need to coordinate with anybody else, doesn't need to coordinate ownership of that. And if it crashes, no activity takes place for, let's say, 5-10 minutes, then the entity, that subscription, gets automatically garbage collected, so you don't need to worry about that. And that's something that is kind of difficult today, and with this change, that's going to be easy. Minimum duration for that is 5 minutes. The message pump programming model addresses another customer concern and also a support concern, to be frank. And that is that everybody writes their own receive loops. Some of those receive loops are written very well. Some of those are written not so well. So we decided that we're going to give you one. That's the on-message programming model. There's also an on-message async version of that. And this model can replace most custom receive loops and effectively turns the model around. There's some control options. Here's the simplest version of on-message, where you basically just supply a synchronous action. There's also one, as I said, where you can see there, where you can supply an async action. And there's also a structure called on-message options that you can go and supply, where you can give us information about, for instance, how many concurrent receive operations you want to allow, or how many concurrent actions we want to go and invoke, which allows you to kind of tune the concurrency of when we invoke those things. And you can actually go and add additional receive loops if you like by calling on message repeatedly. However, you can spin up. But with this simple model, you can't spin down. So if you want to have that kind of flexibility, then you probably want to go and build your own receive loop. So building your own receive loops kind of gets relegated to corner cases, but typically the on-message model is something that will be sufficient. And is the one receive loop to rule them all, available on subscriptions and on queues. Also something that we've been asked for a long time, and that finally arrives, the task-based async API. Everything that we have in begin and end now is available also as async operations returning tasks, so that enables async and await in .NET 4.5. However, the assembly is still at version 4.0, so if you have a dependency on the 4.0 version of the .NET framework, you'll still be able to use the Service Bus 2.0 assembly. However, that will also be compatible. The task-based API that we have is compatible with 4.5 async and await, and obviously that's something that we will push for. So you'll see us from here on likely mostly going to show you examples that use the async style, because it's much more efficient for server-side processing, and so we finally can show you, async API style much simpler. And you can use it much simpler because we now have all these overloads for all those operations, which expands the surface area, but makes the API much more approachable for async operations. But the existing operations begin and end still are there, because the async iasync result API still has some valid uses, and actually you can do some things in corner cases that are more difficult with the task-based API. We're also working on some of the things that we're rolling out right now is improved reliability and scale. We have been going through some rough patches. To be honest, we're based on the SQL database in SQL Azure, and that has mostly been going through some rough patches. But availability is something that obviously we own for you, so we're working on that very hard. So first of all, one thing we're adding is reliable send. So we have an auto retry mechanism inside the fabric. So these are things that are going in the server, kind of on the server side, and automatic partitioning of the system inside. And we will also, in the next 2 months, support larger entities, more scale under the covers. And so you'll see gradual server-side improvements that will deal with some reliability hiccups that we see here and there. We see them very rarely. Obviously, we're all still staying within SLA, but we want to get better. And so we're doing significant work kind of under the cover, stuff that you can't see always, to improve the reliability and make sure that we're staying well above, very comfortably above the SLA that we promise you. One of the significant changes for 2.0, if you're working with server and service at the same time, is that the client library 2.0 will not work against the server. As you might have noticed, the server is something that we ship about once a year, probably a little bit longer than that as a padding. We shipped our first version last fall. We expect to ship the next version probably this fall. And at some point, and we're kind of reaching that point now, there's a point where the service is so far ahead of the server that it's difficult to kind of keep the new library compatible with the older version of the server. So we've reached that point now. So it's not compatible with Service Bus 1.0 for Windows Server. You can still use 1.8, the 1.8 version of the SDK, the 1.8 version of the assembly is fully supported. So you can use that. If you need to have a single assembly, you can use that against server and service. If you want to have symmetry, that will still be maintained, that compatibility. And once the new server comes out, then you're going to have, again, a library that's compatible with both, because then the server will have caught up to the service. So if you need symmetric server service symmetry, then you will stick to the 1.8 version of the SDK. And if you need some features for that, we'll maybe have some help. The task-based wrappers, something I'm going to show you in one of the upcoming episodes, the task-based wrappers for the server for the 1.8 version. That's probably something they want to have. They're actually fairly easy to write. Another big change, another big thing that we're bringing on is shared access signature authentication. We're effectively adopting the model that we have in storage, in Windows Azure storage, and we're bringing that into Service Bus. So it's very much aligned with the model that we have in storage, but we're making this a little bit more differentiated, because you can go and configure authorization rules that are associated with a key in Service Bus, either at the entity level or at the namespace level. And that allows a client to show up and have a key that implies a right, and then they can sign that request with that key, and that's all built into the client. So if you are using that as a from the Windows Azure SDK for .NET, that's all going to happen on the covers for you. The advantage is if you don't need to have the complexity, if you don't need the complexity of the access control service, you no longer have a dependency on that. Also, if there's if there were availability issues with the access control service and or Service Bus, now you only have to deal with Service Bus per se. So the shared access authorization rule that you kind of have in the associated with the entities or with the namespace has the key name, a name for that particular key, the rights that key confers, then the primary and the secondary key that allows you to go and have a primary, have a secondary, and also do key rolling. And I have some samples here. So first is if you were going and setting an authorization rule on a namespace directly with JSON, if you want to do this through Prior HTTP, then you can go and do that here by setting the client certificate for the management certificate. So that's going through the management endpoint, as you can see, where you can go and set the authorization rules on the namespace. On the entity, you're kind of inside the Windows Azure Service Bus SDK, so that's easier. You can go and use the namespace manager and create a new queue description or get one, and then you can go and create one of those shared access authorization rules, have a unique key name, unique within that particular description. You generate a new key, and then that confers the send right. So if you show up with a request that's signed with that key, you automatically get the send permissions, but you can also create a new key that then confers, for instance, manage rights or listen rights. And then you can go and add that to the set of authorization rules, create the queue. And so you can go and build those rights, those accounts that confer keys that confer rights. Those are something for if you have a queue and you want to have a large audience, tens of thousands maybe of clients sent to that queue. So you basically want to make it open, but you want to constrain receiving. So you want to have these asymmetric access rights. You can very easily do that with this model. Authorizing using the shared access key model. So for instance, here my colleague Santosh set that up. So we create a service URI, you create a messaging factory, and then you can go and create one of those new token providers, the shared access signature token provider, and then use that send key name and the send key per se. So that's where the key becomes relevant. You pick the key that you want in the send key, and then you can go and send the message using that. You can also go and use that with HTTP-based applications like this, where you effectively do a calculation that's very similar to what you know from the Windows Azure Storage API, and you can actually go and see that also in the new documentation that we have for that particular feature on the site. So that's all up on windowsazure.com under Service Bus. You also in the MSDN documentation, all those new features that we have in Service Bus in the 2.0 SDK. I want to go and show you those things quickly on slides, and in the upcoming days, I'll also show those things to you in Visual Studio. Thank you for listening, and bye until the next episode here on Subscribe.